Hello friends, my name is Dr. Rajeev Kumar Chauhan. I am a senior member of IEEE. I have done PhD from Indian Institute of Technology, Mandi. Currently, I am working as a assistant professor with the Department of Electrical Engineering at Galgotia College of Engineering and Technology, Greater Noida. I am a former research scientist with University of Manchester, United Kingdom. Today, I am going to discuss about digital logic design, and in this subject I am going to discuss about the basic theorems and properties for Boolean algebra. Okay. So, these are the basic theorems. Like if we have a different switching like a plus 1. So, if we have the a plus 1, so a plus 1, so what does it mean? Actually, what is the meaning of a plus 1 in the circuits? So, these Boolean expression represent the electronic switching. Okay, switch off if we have multi switches. So, for example, a it means a in parallel with a closed switch. Okay, why I am saying closed? Because the switch either it will remain on or off if we are talking about the one way switch. Okay. So, one way switch either it will be on or off. Okay. So, if I am saying it is closed, means if I am saying that in the case of off, in the case of if the switch is off, I have considered it as 0 state, and if the switch is on, I have considered it on. Okay. So, from here we can see, so A is the switch and A plus means OR, it represent OR. Okay. That is the sign of OR. Okay. A or B. So, A or 1. So, A plus 1 is equals to 1. Why? Because A in parallel or represent this plus sign give the information that A is parallel with the another switch which is in state of 1, and 1 I have considered it on. Okay. So, A in parallel with a closed switch means on switch. So, from here we can see this is a switch A and this is the another switch which is in on state. We do not know their name, but we know the state, what is their state, and this is in closed. So, if we have a suppose plus minus, if this is the supply, and if we have a, if I am saying this is some electrical device. Okay. So, if any one of the switch will be on, any one of the switch out of these two, then we will get the some current will flow in this. Okay. It means the device will be on. So, this is the physical significance of this statement A plus 1. So, in A plus 1, 1 will remain always closed. So, it will the current will always flow, it will not affected by the switch A, either it is on or off, because the current will flow from here. If this is on, it will flow from here as well. So, in both the cases, either switch A is on or off, the connected appliance will remain in on states. That is why we are saying that A plus 1 is equals to 1 or on. Okay. So, it will remain on, the switch will remain on, the appliance will remain on, and we in the on state we have considered it as a high state. In the binary number code or decimal codes, in the digital codes, we consider 0 as low and 1 as high, especially in this notification. Okay. And this is annulment, we called this Boolean algebra rules is annulment. Okay. So, main these are not the things we have to remember, but it is up to you. The main thing is this one, because we are going to use these rules to solve the Boolean expressions. Okay. So, for the another case is A plus 0. So, from here I have considered 0 as off. So, A in parallel, because this is a plus sign, it means A in parallel with some another switch, and there that switch has state 0 and 0 is off. It means that switch will be in off state. So, that is why, or it's we can say open circuit. Okay, open. So, this switch is open, which is represented, the state is represented by 0. So, if we this is our some appliance which is supplied by the source. So, as this switch always remain off because of their statement, the state is 0. So, if the switch another switch which is connected in parallel with A is remain in open circuit mode, it means no current will flow from here, no current will flow between these two terminals here and here. Okay. So, to switch on this appliance, what we have to do? We have to switch on the switch A. Okay. If the switch A is on, if the switch A is on, then if the it means on, it means this switch is closed. So, if this switch is closed, the current will go from here and this appliance will on. Okay. And if this switch is off, if I am saying this switch is off, okay, so it means no current will flow. If no current will flow, it means it will remain in the off state. So, what is the significance of A plus 0 is the actual significance is the appliance state is depends on the state of switch A. Okay. So, that is why A plus 0 is equals to A, because this A represents the state of the connected appliance to the switch. Okay. Now, if case number 3, A dot 1 is equals to A. Okay. And we called this rule is identity. Okay. So, A dot 1 is equals to A. What does it mean? In the previous two cases, we have considered it A plus, plus sign is giving the information about the parallel circuit, means two switches are connected in parallel. Okay. It means here is the dot, it means we are what we are talking A in series with closed, because A in series with another switch which is in closed state. Okay. So, if this is the switch, these two switches A and another switch which has their state 1 and both are connected in series. Okay. So, what will happen? If this is our source plus minus, I am saying this plus minus supply and DC supply I have used, and I am saying okay, this is appliance. So, this to switch on this appliance, to switch on this appliance, what we need? To switch on this appliance, both the switches, both the switch A, both the switches should remain in closed state or on state. Okay. So, if this switch is already closed, if this A is on, A is off, or I am saying this is in open state or off state, it means this is in 0. If this A is equals to 0, so what will happen? It means this is in open circuit and it means no current will flow, because of this open circuit no current will flow. It means the appliance will remain off, and if the appliance remain off, so what will we get the output? Output will be 0. Okay. Now, case number 2, the switch A state is now changing from 0 to 1, it means on. We have switch on this switch A. Okay. So we can flow, the current will flow from here to like this, and the appliance will connect across the power source and it will switch on. Switch on means if the appliance is on, the output, what will be the output? On is represented by 1, it means the state is 1. So, whenever the value of A is 1, we get the appliance is on or remain in one state. Whenever as the value, as the state of switch A is changing from on to off state, the appliance also switched off. So, this is the meaning of A dot 1. So, if this A dot 1 is equals to A, because if we will put it here like A is 1 is equals to, because if A is equals to 0 dot 1 is equals to 0, if A is equals to 1, then 1 dot 1 is equals to 1. Just leave it. If A is equals to 0, so 0 dot 1 is equals to 0. Okay. So, I think this is clear. This is also called identity rules and the name of this. So, now next one is A dot 0 is equals to 0. So, from dot 0 means 0 state means the switch is, whatever the switch is given, that is in off state. Okay. If the switch is in off state and that is connected in series with the another one. So, for example, here the connections will be like this. So, if this is the state, okay, if this is the state, both the switches, this switches remain off state. So, if this A is also off, it means both are in 0 state. So, if we have the plus minus from here and if I connect it like this, so current will, no current will flow because of this open circuit. Okay. So, no current will flow when both the switches is on in off state. Okay. Let us move the, now I have switch on the switch A on. Okay. Now, the current, how the current will go, but here again the open circuit, it means still no current will flow. Okay. It means in both the state, either switch A is on or off, in both the state the appliance will remain in off state. Okay. In off state, and therefore, I am saying that A dot 0 is equals to 0, because 0 represented by off state. 0 represent the off state in both the state annulate. This is also called annulant. Okay. Now, Boolean expression third. We have two switches A and A, both the switches are A and A. So, A, what does it mean? Plus sign represent that A in parallel with the another A. Okay. So, we have two switches, but the notation for both the switches is A. Okay. So, and parallel plus sign represent that both the switch are connected in parallel, as I have discussed in my previous slide. Okay. So, if both the switches are off in the off state, so whatever, if one of the switch will be on, from here we can see this is plus, this is minus, and this is the switch. Okay. So, from here if both the switches in off state, on means 1 and off means 0. This is closed state or this is open state. Okay. So, initially we can see from here both the switch are open, means in off state, if both the switch are in off state, it means we do not have the path to supply this appliance. Okay. If we do not have the path, it means circuit is not closed. It means the output of the means the appliance will remain in the off state. So, whenever the value of A, both the A is 0 0. So, 0 plus 0 we will check 0 plus 0, the output will remain 0. Okay. Now, so whatever the state of the both the switches, the output will remain A. Okay. So, now next case, if I have switch on the one switch. Okay. So, now we can see from here the current will go from. So, the path is now path is complete to supply the appliance, and we can say the output is, what is the output? It will remain in on state. So, any one of the switch like 0 plus 1, for example, I have considered this is in 0 state, this is in 1 state. So, 0 plus 1 is equals to 1, and that is equals to what? A. Okay. So, this will remain in on state. Okay. Now, I have also switch on this one. Okay. So, it is 1 plus 1, both if both the switch is high, the current will go from here as well as from here. Okay. It will depends on their internal resistance, the current will flow. Okay. In both the whenever both the switch is high, the output will remain, the switch will glow. It means A plus A is equals to A. It will depend on the state of the switch. Okay. If one of the switch is high, the output will be high. Okay. Now, next one is the A dot A is equals to A. So, dot represent for the series connection, means two switches are connected in series. Okay. So, two switches are connected in series. So, it will looks like this one. Okay. So, both the if both the switches are at off state or at 0 level. So, from here we can see 0 dot 0. So, we will get the output, any current will flow. If I am saying this is plus minus, no current will flow. Okay. Now, I have switch on one switch. Okay. One switch on. So, one switch on, still this is open circuit, means no current will flow. So, now this will be 0. Now, I am saying 1 dot still 0, because no current will flow. Okay. So, now next one is the both the switches are closed. Okay. If both the switches are closed, it means we get the path to supply the power to this appliance. Okay. Now, this appliance will be on. So, 1 dot 1 is equals to what? 1. Okay. So, that is why A dot A is equals to A. Okay. Now, next case is A bar is A double bar is equals to A. What does it mean basically? So, A bar means bar represent the note of whatever the input we are giving, the output will be invert of that. Okay. So, for example, if I am giving 0, so 0 1 bar represents the note. So, if I am saying this is A bar, the output will be what? Output will be 0, but A double bar means A bar and then whole bar. So, I have given 1, if I am saying A is equals to 0. So, A bar is equals to what? 1. From here it will just invert it. Okay. And if the A bar is 1, then what will be the value of A double bar? Because A double bar is equals to of this. So 1 inverse, and that is equals to 0. So whatever we have given, we get the same output. Okay. So this is the main part of this question. Okay. Then A plus A is equals to this, B. Now this is the another rules in this case. So A plus A bar is equals to 1. Okay. A plus A bar is equals to 1. How this is happen? So as I have said, the A bar represent the note value, whatever the input is given. Like for example, in this case, if I am saying A is equals to 0, so what we will get? A bar is equals to 1, and if I am saying 0 plus 1 from here, or this 0 plus 1, if I am saying 0 plus 1 means one switch is 0 plus 1 means A bar means if the A in off state, then A bar will be in on state, and if A is in on state, A bar will be in off state, and because of this sign, positive sign, both are connected in parallel. Okay. So we will get the output always 1, because if A is equals to, if this switch is closed, this switch is open, then we will here just add one switch. Okay. So the current will go from here, and if this one is closed, so it will become open, so the current will go from here. In both the cases, either A is equals to 0 or 1, in both the cases the output will remain 1, or appliance will remain in off state. Okay. So this is all about this circuit. So thank you very much for your time, and if you have any query till now, you can write down an email to me on rajeevnitj@gmail.com. Thank you very much.